Okay, let us start electrochemistry subjective type numerical. Question number 11 we will see. 11th question, let us read. The voltage of the cell given below. The voltage of the cell given below is minus 0.46 volt. So the cell is given here. Cell is given is platinum, hydrogen gas, NaHSO3 0.4 molar, Na2SO3 6.44 into 10 power minus 3 molar. It is a salt bridge. It is a salt bridge. It is Zn2 plus 0.3 molar. This is the zinc solid. Okay. Also, Zn2 plus 2 electrons gives zinc E0 value is given. Calculate the value of K2. K2 in the sense second acid dissociation constant. Second acid dissociation constant, where K2 equal to concentration of H plus into concentration of SO3 2 minus by concentration of HSO3 minus. Okay. Now you see that it is a salt bridge. Salt bridge right side you see what is there? Zinc rod is dipped in zinc ion solution. Therefore, it is a metal ion electrode. It is metal ion electrode. This if you see left side, if you see salt bridge left side, you see hydrogen gas is there. And what is the salt solution means? In the salt solution, what is there? NaHSO3 and Na2SO3 is there. NaHSO3 and Na2SO3 solution is there. In this solution, what is there means H plus ions are there. Therefore, it is called a hydrogen electrode. Therefore, it is called a hydrogen electrode. Hydrogen electrode is a gaseous electrode. We cannot connect. Therefore, only we are taking platinum as inert electrode in order for external connection. Therefore, salt bridge left side is a hydrogen electrode. Salt bridge right side is a zinc electrode. For zinc electrode, E0 value is given. For zinc electrode, what is given in the sense E0 value is given. What they are asking in the sense they are asking K2 value. Acid dissociation constant they are asking. Okay. How to find acid dissociation constant? That point we will see. Let us start solution. We will write a solution for this question. Solution we are writing. Here one electrode is zinc electrode. Sorry, okay. Here one electrode given is what in the sense zinc electrode is given. Zinc electrode is given. For zinc electrode SRP is for zinc electrode SRP is how much in the sense minus 0.763 volt. Minus 0.763 volt given. Another electrode is what means SRP of hydrogen electrode. Another electrode is SRP of hydrogen electrode. SRP of hydrogen electrode is 0 volt. Now you say that which electrode, zinc electrode and hydrogen electrode, out of these two, which will act as anode? One is having lower SRP. This is having lower SRP, therefore it is anode. So we can write anodic off reaction. We'll write anodic off reaction in that zinc is undergoing oxidation to give zinc aqueous plus 2 electrons. Then we'll see cathodic off reaction. We'll see cathodic off reaction in the sense hydrogen electrode. In a hydrogen electrode, which is undergoing reduction at cathode, H plus aqueous, that takes electron and gives hydrogen gas. Hydrogen gas. For balancing, we'll keep off. Here number of electrons 2, here 1. In order to make gain and loss equal, let us multiply this by 2. Okay, we multiplied by that by 2. Now we will see cell reaction. We will see cell reaction. In the cell reaction, we are taking zinc in the zinc left side. We are taking 2H plus aqueous. We are taking and the electrons are cancelling. Zinc ion in the right side and of the one H2 gas. Hydrogen gas we will write here. Here we will write hydrogen gas. Hydrogen gas we have written. Okay, we got the cell reaction. Here you have to understand this point. Cathodic reduction, very cathodic process you have to understand very clearly. In the cathode we are taking how the cell in the sense in the cathodic electrode how it is there. We will see again. In the cathode you are taking a salt solution. The salt solution contains what are the substances in the sense NaHSO3 aqueous and Na2SO3 aqueous NaHSO3 aqueous concentration is given 0.4 molar. Na2SO3 aqueous concentration given as a 6.44 into 10 to the power of minus 3 molar. We will keep platinum wire. It is a platinum rod, platinum foil. It is coated with the platinum black. It is coated with the platinum black. Then we are passing hydrogen gas here. We are passing hydrogen gas here. Hydrogen gas. This is the hydrogen electrode. It is a hydrogen electrode which is given in the question. In the hydrogen electrode, how the hydrogen electrode given in the sense hydrogen gas we are passing, and H plus ions how we are taking in the sense in the form of these two salt solution. In these two salt solution, this NaHSO3 we can write as Na plus aqueous and HSO3 minus aqueous. This HSO3 minus aqueous can give H plus ions. So solution is having H plus ions. Therefore only we are saying this is as hydrogen electrode. So at cathode which can undergo reduction in the sense H plus can undergo reduction. So don't write HSO3 minus or SO3 2 minus like that, don't take. You take H plus as H plus we have to take. H plus is undergoing reduction. You may be asking another question here. SO3 2 minus is there? No. SO3 2 minus why can't it undergo reduction? That means if it is so, they would not give hydrogen gas. They have given hydrogen gas in the sense H plus is undergoing reduction. That's why. Sir. So from this point, from hydrogen gas, they have given hydrogen gas. This indicates that H plus is undergoing reduction. Okay. So H plus plus electron gives hydrogen gas. So we got the cell reaction. Sir. Now what they are asking us to find? They are asking us to find K2 value. They are asking us to find K2. K2 they are asking. Sir. What is K2 that we will see? For which we will take sulfurous acid. Sulfurous acid formula is H2SO3. Sulfurous acid on dissociation gives H plus ion and HSO3 minus ion. For this equilibrium constant we will write. For this we are writing equilibrium constant, that is called Ka, acid dissociation constant, that is equal to, right side we will write in the numerator, that is H plus into HSO3 minus. Left side we will write in the denominator, that is what in the sense H2SO3. It is Ka. Now we will take this HSO3 minus, we will take HSO3 minus. This HSO3 minus can give H plus ion, and remaining is what means SO3 2 minus. For this we will write equilibrium constant, that is called acid dissociation constant. Right side we will write in the numerator, that is H plus and SO3 2 minus. Left side we will write in the denominator, that is HSO3 minus. Now for this Ka is called Ka1, this Ka is called Ka2, because it is first step, it is second step, therefore it is Ka2, it is Ka1. Now they are asking us to find what in the sense Ka2 we have to find. So we have to find this Ka2. They are asking this Ka2. So for which we have to substitute the values. Now we want a concentration of H plus. Concentration of H plus we want. Concentration of H plus is given or not given? You see that here. Concentration of H plus. What is given? NaHSO3 is given. Sir, NaHSO3 concentration is given. They have given the value NaHSO3. This NaHSO3 is a salt, so it undergoes complete ionization and gives Na plus and HSO3 minus ions. Now Na plus aqueous concentration is how much in the sense 0.4 molar. HSO3 minus aqueous concentration how much means 0.4 molar. Okay. Now let us see this point again. NaHSO3 concentration given 0.4 molar. NaHSO3 is a salt, so it undergoes complete ionization. Is it correct? Is it correct or wrong? We have taken complete ionization. Whatever the salt. Salt means strong electrolyte, we are saying. Sorry, okay. Strong electrolyte means can it undergo 100% ionization? No. Strong electrolyte in the sense it can undergo to the higher extent of ionization. Then how do we take complete ionization? because they did not say what is the extent of ionization, they did not say, so that we have taken complete ionization. Okay, therefore concentration of Na plus is 0.4 molar, concentration of HSO3 minus is 0.4 molar. Okay, now we know which value in the sense from this we know bisulfite concentration. We know bisulfite concentration. Sir, next value we will take Na2SO3. We will take Na2SO3. We will take. Now we will take Na2SO3. We are taking Na2SO3 is a salt. It undergoes complete ionization, so it gives 2 times Na plus ions and SO3 2 minus ions. Na2SO3 is a salt. We have considered it is completely ionized because they have not mentioned extent of ionization. That's why we have considered. Suppose if they mention extent of ionization is 80%, then we have to consider 80% ionization only we have to consider. Since they have not given, we are considering complete ionization. Therefore, now what is the concentration of Na plus and sulfite we will see. Now Na2SO3 concentration given, that is 6.44 into 10 power minus 3 molar. That value we will take. It is undergoing complete ionization we have assumed. Therefore concentration of sulfite is 6.44 into 10 to the power of minus 3 molar. So we know the concentration of sulfite. Concentration of sulfite we know. We know the concentration of sulfite. Sulfite concentration is known. Bisulfite concentration is known. Ka2 we have to find. Then that means we have to substitute concentration of H plus. So how to get concentration of H plus? In order to get concentration of H plus, they have given this cell reaction. This cell reaction is given for what sake in the sense? This cell reaction they gave for what sake in the sense in order to substitute this H plus value. So this H plus concentration we have to get from this cell reaction. So we will take this cell reaction. By taking this cell reaction, we will substitute this H plus concentration. H plus concentration we will substitute. Sorry, okay. Now this cell reaction in the sense for this cell reaction we will write cell potential we will write. So cell potential for the cell reaction. Cell potential for the cell reaction is equal to E naught cell minus 0.059 by n log of QC. Now cell potential and E naught cell we have written. Here QC we have written. QC is what in the sense? QC we will write. QC is what in the sense? Right side what is there that you write in the numerator. Left side what is there that you write in the denominator. So right side zinc concentration, pressure of hydrogen gas, and denominator H plus aqueous square, that we will write. Okay, so QC is equal to what in the sense? Right side we will write in the numerator. Right side is zinc ion is there, that concentration. Right side hydrogen gas is there, that pressure we will write. Left side H plus aqueous is there, that concentration we will write power 2 we have written. Why power 2 in the sense stoichiometric coefficient is 2, that's why power 2 we have written. So we got QC. Okay, we got QC. So in the QC is what means this one. In the QC here zinc concentration is given. Zinc concentration, is it given or not? You see in the question, if you see zinc concentration is given, that is how much means 0.3 molar is given in the question. Sorry, concentration of zinc is given. Okay, we know the concentration of zinc concentration we know. Pressure of hydrogen gas we will see. Pressure of hydrogen gas in the question, if you see pressure of hydrogen gas, they did not give. Pressure of hydrogen gas they did not give in the sense what is the meaning of that one means we have to take that as 1 atmosphere. Why should we take pressure of hydrogen gas they did not give? That means either we have to find, otherwise we have to see another route. Some other route we have to see. Well, how can we take the one atmosphere? We may be asking that question. For that they are asking Ka2, for which we want H plus concentration. They are asking Ka2. Ka2 we want means we have to substitute these values. We know bisulfite and sulfite. We want H plus, for which we came for this equation. So we have to find this H plus concentration. If we find H plus concentration, then only we can find Ka2. So here H plus concentration is the unknown term. H plus concentration is the unknown term. When it is unknown term, how can we take this also? And this also how to find? Of course, they have not given. So we are assuming that it is 1 atmosphere. Sorry. So pressure of hydrogen gas is 1 atmosphere we have considered. Sorry, okay. Then we will see N. N is called number of moles of electrons. Number of moles of electrons, if you see how many electrons transferred, you see loss is 2, gain is 2. So we know number of moles of electrons. Sorry, okay. Number of moles of electrons we know. Now we will go for this equation. We'll see this this formula we will take. In the cell potential we will substitute. Cell potential given is how much, means minus 0.46 volt is given. Now E naught cell we want. We have to substitute E naught cell. We have to substitute. So E naught cell is equal to SOP of anode. SOP of anode plus SRP of cathode. SRP of cathode. Cell. SOP of anode will substitute. Here anode is what? Zinc. For zinc, SRP is given minus 0.763 volt. So let us substitute SOP. SOP is what? Plus 0.763 volt. Plus cathode is what? Means hydrogen electrode. For hydrogen electrode, standard potential is 0. For hydrogen electrode, standard potential is 0. So we got E naught value. E naught value is 0.763 volt minus 0.059 by N is called number of moles of electrons to log concentration of Zn2 plus is given, that is 0.3 molar. Pressure of hydrogen gas is 1. Now concentration of H plus square. Okay. Now we will get concentration of H plus. We will get concentration of H plus is equal to 4 into 10 to the power of minus 6 molar. So we got concentration of H plus. Okay, we got concentration of H plus. Now we will go to Ka2. This Ka2 formula we will take. In this Ka2 formula, let us substitute H plus concentration, sulfide concentration and bisulfide concentration in order to get Ka2. Okay, now we will substitute in Ka2 formula. So Ka2 is equal to what formula means? H plus concentration into SO3 2 minus concentration by bisulfide concentration, HSO3 minus concentration. Concentration of H plus we found as 4 into 10 to the power of minus 6 molar. Concentration of sulfite we found as 6.44 into 10 to the power of minus 3 molar. It is given. Then concentration of bisulfite given is 0.4 molar. Concentration of bisulfite. Now we are getting Ka2. Ka2 is 6.44 into 10 to the power of minus 8. Ka2 is 6.44 into 10 to the power of minus 8 is the answer.